Okay, welcome everybody. It's an absolute pleasure to be here and to have the opportunity to talk with you all and to have such a great bunch of talks ahead of us. So I'm just going to be very short, just very brief introduction. It's been some time now since there's been a real review of the evidence for different forms of unconscious learning. Axel did one a few years ago, but it's been a while since that. And there's been a lot of advances since then. There's been advances in experimental methods with the likes of David Shanks doing a really good job in terms of identifying common failings and helping us identify key requirements for making claims about, rigorous claims about consciousness. There's been advances in the analytical methods that are being used with the likes of Zoltan DNS and others driving the adoption of Bayesian methods and other methods as well to better test our hypotheses. And there's also been advances in the wider scientific practices with pre-registration and register resorts, helping drive up the rigor of what we're doing. So there hasn't been a better time, I think, to reassess the evidence for different forms of unconscious learning. And it's hoped that these 4 talks will go some way to help with that, capturing our current understanding of the limitations of unconscious learning, and perhaps in doing so, help us get to that bigger question of the adaptive function of consciousness. So I'm just going to introduce the talks and then we'll have a little bit of time at the end. We'll have 5 minutes of questions after each of the talks, so you can ask questions then, but then we'll also have that short period of 15 minutes where we can all come up and you can ask questions again at the end. Okay, with that, I will hand over to Lena Scorer, the first speaker.
Hi, everyone. Oops. Can you hear me okay? Yeah, okay, brilliant. So what I'd like to talk to you about is to introduce a few different studies that we've been doing with Ryan over the last few years. So I'll just note over here that it's going to be deliberately loaded with results, but if you're interested about the actual details, then you can always come and find me afterwards. So in order to get the point across, I would like to conceptualize learning in terms of ascending complexity. So at the lower end, at the simplest end, we have learning of very simple associations, which is also evident in simplest organisms. And at the top end, we have complex action-related contingencies, so things like reversal learning, counterfactual learning, and so on. And in the middle, there's a whole host of things happening. So we have learning of reflexes through classical conditioning. We have learning of emotional and physiological responses, such as fear conditioning, evaluative conditioning, and we have instrumental learning. So instrumental behavior, such as approaching rewards, avoiding punishments, and so on. So obviously, they did not develop in such clear-cut lines as I'm showing here, but I think this is a useful depiction for showing the interplay with consciousness and trying to demarcate at which point the consciousness is necessary for learning and or isn't. So today you could read this literature in this way. So the simplest forms of learning don't appear to need conscious access. That's the prevailing evidence, although it's not very clear. While the complex action-related contingencies do seem to require conscious access. But the middle bit has been a gray area for quite some time, since it has been shown that instrumental learning, which is where I will begin today, initially was shown that it is possible, but recent evidence, including our work with Ryan, has been showing that, in fact, it might not be. And this is where I will begin today, going down from instrumental learning through fear conditioning and some simpler associative learning. So here's an example of a task that we use to study instrumental learning. So this is a conscious case where we have a simple stimulus, which can be positive or negative, and that means positive stimulus would bring a reward if approached, and negative stimulus would bring a punishment if approached, and symmetrically the opposite. So here the participant made an approach choice and they were rewarded. So it seems like a very simple decision, especially if the task is deterministic, as we often do here, but actually there's a lot happening under the hood in this case. So not only we have to process the stimulus for expected value, decide, choose the action and process the outcome, but we also have to relate the outcome to the stimulus and the action that we took, and then update that stimulus value. So that's basically a Calais depiction of reinforcement learning over here. So seems simple, but it's a complex process. A lot has to happen in the brain for that learning process to be to be implemented. So here's what we do in the unconscious instrumental learning task. And this is the paradigm that I'll show you a few variations of. So we put the stimulus between a forward-backward mask to render it unconscious. And the rest of the decision process stays the same. So here we typically use a low contrast cue, allowing for very long durations, so even up to 200 milliseconds, which is supposed to maximize learning. Some previous evidence shows that longer durations in subliminal tasks can actually enhance the effect. And we establish the duration in a staircase task, so the duration is different for every participant that we have. The second change we implemented to enhance the sensitivity of this kind of tasks is a trial-by-trial awareness check. So in this case, we ask about an objective property of the stimulus that was presented, for instance, the symmetry of that cue, and we ask for confidence in that judgment on a binary scale, in this case, between confident and guess. This allows us to mark all the trials which participants were aware of, if they were correct and confident in their assessment, and exclude them. So here are straight into the results of the first experiment in this line of research, where we have looked at unconscious instrumental learning. So as you see over here, we looked at type 1 D prime to assess learning. So it's simply a measure of sensitivity between those two stimuli. And as we can see, it was not different from 0, suggesting that participants could not, in fact, discriminate between the two stimuli and behave accordingly. On the right-hand plot, you have the learning curve, which is basically flatlining at 50%, so perfect chance performance. And the behavior was quite erratic and quite random. Participants could not learn from those unaware trials. Now, for comparison, here is what happens in the aware trials. So I'll note here that there's actually not many of them because the staircase settles on the unaware trials very sensitively. So it's only a few momentary moments of awareness, so to speak, that people can actually see the cues. But even then, we have the D prime that is significantly over 0, suggesting that participants obviously can discriminate between the stimuli. And you have the learning curve also going up. So this was trace conditioning, which basically simply means that there is a temporal delay between the events in the task, so between the stimulus, the action, and the outcome. But previous work suggests that maybe if you bring those events closer in time, even up to the point of overlap, then you might bring about learning. So this is what we set out to try next. We used continuous flash suppression to that end. It allowed us to present the stimulus for even up to 2 seconds, during which time participants could make the response, approach or avoid, and get the outcome delivered. So here the outcomes were actually tastes. So the reward was a really nice chocolate milkshake, and the punishment was a really yucky salt and quinine mix. And participants got those delivered through little tubes, while the stimulus was still on screen, obviously suppressed with CFS. Did that have an effect? It did not. So the D prime was not significantly different from 0 in this case either. Looking at the unaware trials on top, we again have very erratic behavior and no evidence of any upward learning curve. And again, in the aware trials, we had a significantly a D prime significantly over 0, suggesting presence of learning. And in this case, the learning curve looks even nicer, going up to about 80% and then plateauing there as it should. Okay, so there's no behavioral evidence of learning at this point. So what we wanted to do next is to see if we can find any indicators of learning taking place, any precursors of learning taking place, even if we don't see any behavioral evidence of it. So we looked to physiology to do that, especially local heart rate changes. So here's an effect called heart rate deceleration, error-related heart rate deceleration. And what typically happens is that when we make a mistake in our behavior, then and we get delivered the outcome, the feedback, then our heart rate drops for a few seconds. So here we have heart rate change in milliseconds. So basically, the bigger the change, the higher the curve goes. So upward trend is actually deceleration. So when the outcome was punishing, feedback valence punishing, the orange line, we have a very large deceleration, and that's something that doesn't happen for rewarding feedback. That means that participants have been learning the contingencies in the aware trials. And if we do see some indication of something like this in the unconscious trials, then we might have some reason to believe that the brain is actually learning the association between the feedback and the stimulus, even though we can't act on it yet. That didn't happen though. So in the unaware trials only, we have absolutely no difference between the rewarding and punishing feedback in terms of cardiac deceleration, suggesting that it's not only that the behavioral evidence is missing, but rather that the brain has no possibility of processing the feedback as it should. Our next question in this line was to see if any kind of learning prior to unconscious instrumental stage can enhance the effect. It could be the case that having learned the associations consciously, they can then be enabled for unconscious performance on the same task. And that's what we did here. It's a 2x2 design with 2 learning stages, conscious and unconscious, and 2 performance stages, sorry, 1 performance stage, sorry, which was always unconscious. So let's look at the results of the learning stages first. So on top in orange, you have conscious learning. And here we're not talking about simply conscious trials, but rather an entirely conscious aware block. And we have, as you can see, very quickly, participants were able to learn the stimuli and hitting the ceiling in basically 20 trials, which is not surprising for such a simple deterministic 2-stimulus task. And in unconscious learning, a curve that you know well by now, basically nothing was happening, very erratic behavior at chance. But the interesting thing, so what happened in unconscious instrumental performance following conscious learning? The answer was nothing. Even after those associations were learned really well, as you can see from the conscious learning curve, participants could not act upon those associations and perform instrumentally above chance. And that was no difference between the unconscious performance following conscious learning versus following unconscious learning. So any kind of previously acquired knowledge did not help, is the short story. Last study in this line of research is something that's still not published. It's currently submitted. And that's the variation to this paradigm. We have been getting lots of comments that, okay, your stimuli are neutral. The task is very simple. What about if you change it? Maybe there is a way to maximize learning in this task. So that's what we've done. Here you see that we use faces as biologically relevant, ecologically valid stimuli with the idea of potentially maximizing learning in this way. And they were angry versus neutral faces from the same actor, angry being predictive of punishment if approached, neutral being predictive of reward. And here you might be thinking, why not happy? Well, happy are usually smiley. So we found that to break through the masks really quickly and people could see those faces quite a lot. We also changed the approach avoid decision to alternative force choice. Previously, we simply used approach as a active choice and avoid as a kind of withdrawal, go no-go style. But here we thought maybe constraining those responses can actually help to maximize learning in some way. So what happened here? Again, we have the confirmation of the same effect. So when learning was conscious, we had it was very quick to hit ceiling. It was very easy to learn. But in the same task, when it was unconscious, we again found no evidence of instrumental learning whatsoever. So to briefly summarize the instrumental bit, visually masked stimuli do not seem to produce instrumental learning or its precursors, even when the stimuli are naturalistic and when the responses are constrained. And they also seem to preclude unconscious performance even after previous conscious learning. So our next stop was then to take this method and apply it to learning at a lower level. The idea was that we wanted to try to demarcate when does the effect potentially change. So maybe we need consciousness, we need consciousness, sorry, for instrumental learning, but if we use the same method for a simpler kind of learning, perhaps we don't. And we relied on a previously applied task using faces as the CS plus CS minus. So as you see over here, we have an angry face as the CS plus, which was accompanied by a very nasty 50 millisecond white noise burst as the US. So it was on a 75% reinforcement schedule. And we had a phase versus no phase judgment as the awareness check, which again permitted us to exclude all the aware trials from the task. The metric of conditioning here was skin conductance response. And just as a comparison, here was our CS minus, which was simply no phase. And we wanted to do it as phase versus no phase, as opposed to, for example, female and male phase, which has been done before, because we thought it's actually a more sensitive measure of learning. And it's easier to learn from seeing something versus seeing nothing, rather than distinguishing between two identities. Second reason was actually those two genders might not be a reliable metric of learning, because it's easier to maybe pick up on a single feature of the stimulus rather than being able to tell whether it was male or female. So that was the task. Let's look at the conscious state conditioning first. We wanted to do that to assess if the paradigm holds and if it can be used for the unconscious condition. As you see, the left-hand bar is a true aversive. That's our CS plus with US. It causes a pretty large skin conductance response, as it should. And the comparison of interest here is actually the safe versus aversive as safe. So safe is our CS minus, aversive as safe is the CS plus, which was not accompanied by any kind of noise. And this is where you should be seeing a difference if the paradigm is working. This is work in progress. So we have not hit the pre-registered base factor yet, but as we are collecting more and more data, we see that it's going up towards the top boundary, suggesting that there is a difference. Now, more interestingly, unconscious state conditioning. So here I'm showing you the plot for the first half of the task, where previously the effect was shown to reside. So typically what happens in unconscious studies is that the effect should manifest quickly and then dissipate. That's at least what's been shown before. Here we can see that there is no difference between those two conditions, two cues of interest, so safe and aversive as safe. So judging by this, we are not seeing any evidence of unconscious state conditioning yet, bearing in mind that this is work in progress. However, the base factor here is tending towards the lower boundary as we are adding more data. Just for comparison, this is around 2 out of 2. So this is the second half of the task, where again, there seems to be little if no difference between those two cues in skin conductance response. And the final stop I want to make in this kind of hierarchy of complexity of learning is associative learning, and a study of Ryan, which actually is a few years old now, but I think completes the picture really nicely. So here we have a case of simple associative learning in the visual domain, where participants were learning to associate names with professions. So here you can see that Paul is a banker and not a pianist. This was also done in that study in purely auditory domain, as well as across domains, so auditory to visual. And the effects of this task is a very clear priming effect, as you can see. So participants were actually faster to respond to the discordant pairs. So Paul being a pianist and not a banker as he should be, which is consistent with the inverse priming effect. So it seems to be the case that participants were able to learn those associations sufficiently to have an effect in their reaction times to those choices. How am I doing for time? Oh, great. Perfect. Okay. So to summarize, going a level down from instrumental learning, visually masked stimuli do not appear to permit fake conditioning either when awareness is controlled for in this trial-wise manner. So this is in contrast to some of the past evidence showing that it is possible with CFS. So it could be the case that maybe the masking method is making all the difference. Maybe it's too strong simply, or we need some kind of more permissibility in conscious access. It's also possible that maybe skin conductance is not the appropriate readout of this. People have used startle reflex, for example, or heart rate changes as well to study this. So like I said, this is a work in progress. So we will have some amendments to the paradigm as well. But if it holds, it might actually not be that surprising, as we will see from Gautam's talk soon in terms of peer conditioning. And finally, on the lowest level, we have visually masked stimuli appear to permit unisensory and multisensory associative learning. So in this priming-based way, very simple kinds of learning. So to summarize this, we have evidence that consciousness does seem to the learning does seem to depend on the level of conscious access. So simple kinds of learning, priming-based kinds of learning, the stimulus might be processed enough to permit for this kind of simple association to be built. But once learning reaches a sufficient complexity, as we have seen from that circular diagram in instrumental learning, the unconsciously presented stimulus simply might not be strong enough to be able to cause this kind of broad distribution of activity. But this is something to be assessed with connectivity analysis, for example, which is also something we are thinking about. Now, why do we have this kind of difference? Well, this is a bit of a speculation. My instinct is that once behavior becomes complex enough to require action to have to be flexible, to be reversed quickly and fast, then simply this cannot happen in an unconscious way. And I think we'll hear from the last talk from Professor Jablonka about a potential nice theoretical and conceptual approach to this. So I won't speculate at this point, and I'll stop here. So thank you very much for your attention. Special thanks to Ryan, who was involved in a lot of this work, and I'm happy to take questions.
Thank you. Yeah, it's okay now. That's better. So we got 5 minutes for questions. I'll be happy to run this around. Hands up. So yours first. So there you go.
Yes, thanks very much, Lena. It's very good stuff. Obviously, it seems like learning on visually masked stimuli is very limited. The debate is then what explains this difference. There's this sort of critical line of thought from Haquan Lau and Matthias Michel and people in that sort of higher order group on which the difference is to be explained not by the presence versus absence of consciousness as such, but rather just by the signal strength. And they say it's very important to distinguish these things. What's your sort of reaction to that sort of line of criticism?
So do you mean signal strength in terms of what degree of activity the unconsciously presented stimulus can provoke?
They say that by masking the stimulus, you made it weaker.
Yeah.
And that weakness is a more plausible explanation for the impoverished learning than presence versus absence of consciousness.
Yeah, but yeah, I would definitely agree with that. But I think they're actually connected points. The weakening the stimulus is weakening the conscious access that you have to the stimulus. So I don't entirely see why there should be different explanations, especially that you do seem to have different learning effects if you use CFS. I will flag here that not for instrumental, because we have also used instrumental learning with CFS and we also found no effect. But then when you think about even more permissibility, like in implicit learning tasks, which I think Hazwan will talk about, then you see evidence of instrumental learning. So I think it's definitely some kind of gradation, whether it's in signal noise or in conscious access, not sure, probably both.
Hi, Georgia Mason.
Hi.
Lovely talk. And you know, I'm going to ask this. Would it make a difference if you manipulated the awareness of different elements of the task? So you've just looked at the cue that tells you what to do, but what about manipulating the proprioceptive feedback you get from doing the action, or manipulating awareness of the reinforcer or punishment?
Yeah, I think that would be definitely really interesting. I think it's a different question though. We are trying to specifically think about the degree of consciousness the consciousness of the stimulus that you need to drive learning. So whether or not it would be different for instance, masking the reward, I think it has also been done in Simon van Gaal group a while back. Yeah, but I don't know. I'm not so well versed in that. I think it's definitely different conceptually.
Did you have a question? No, sorry. David. Yep. Thanks very much. Very impressive set of studies. You sort of touched on this, but if you had found apparent evidence of unconscious learning in the instrumental cases, a possible response of a critic might have been to say that your awareness test is a bit unfair because you're asking the participants to distinguish, let's say, between whatever they were, neutral and angry faces or something like that, which requires an identification. And actually the conditioning could just be based on extraction of some differential feature. So I just wonder what
you know, what you would do in future experiments if you wanted to try to avoid that kind of potential response?
Yeah, we were aware of that issue, certainly. We chose to go this way because doing it in this kind of discrimination way, telling the difference between the two, was causing the stimuli. We would have to present the stimuli sequentially, which could abolish learning for a different reason, simply that you might not be able to integrate them across a time gap. So it was simply a trade-off, something that we decided to do, but it's a valid criticism. And maybe Ryan has a.
Can I add to that?
Yeah.
David, it's a really good point. And we did realize afterwards, and if the fear conditioning study that Lena presented, that's why we changed it. So in that, for exactly that reason, the previous ones, and I found it myself when I piloted the study, you could tell what you're asking people to get this trial by trial test of awareness is, was it a male or female face? And I could look at it and say, I have no idea whether it's a male or female face, but I know I'm about to get the noise because there was a darker area there, which is exactly your point. Fortunately, in none of the studies where we've done it, because we did the same thing with the symmetry judgments, the same criticism could be applied to that. Fortunately, in none of those did we find unconscious learning, so we know we haven't got a false positive there, but it could have been had we found that. So that's what we've done differently, and that's why we have to have this no face versus face in that fear conditioning study, which is going to require a separate control condition, obviously, but it should both address that issue, so we're getting more rigor in that trial by trial test for awareness, and make it more sensitive potentially at the same time, because it should be an easier association to make. But we got there, a little late. All right. Any more questions? You want to go another question? One last question? Yep.
Yeah. There's no one else and there's time. I'll take the opportunity. Just on that last point, I wonder if it is a criticism one could make about the alleged demonstration of the simple associative learning unconsciously, that if subjects were saying, I did not see or hear a name or a profession, there might nonetheless be elements of the phoneme or the shapes, if it's visual or auditory, and that in principle, the associative learning could be based on that.
Mm-hmm. Brian should take it because it was his study. Please do.
It's a reasonable point. I'd have to go back and look at the details of what we were doing. It's the case that every study we do, we're up in the rigor. Thanks to David and others for pointing out these things. We are constantly doing that. So I'd like to go back to that and have a look whether or not it was subject to those sort of things. It's one of those studies which was really quite compelling because of the number of different ways we did it. But I don't know is the short answer. I think it is worth us looking at that in more detail. I couldn't be absolutely certain on that. Okay. Right. Well, at that point, thank you, Lena.
Thank you.
And next up, we have Razvan Jurkis, and he's going to be talking about implicit learning of complex structures supporting evaluative conditioning and instrumental responding effects.
Okay, thank you very much. I'm really happy to be here. It's my first oral presentation in the ASSC. So I'm going to talk about a different approach to the questions that Lena has also addressed, and others as well, in which we attempted to test whether there can be unconscious conditioning effects by using not subliminal unconscious exposure of stimuli, but rather complex structures, complex stimulation that is difficult to be detected consciously. So, as Lena has clearly showed, and as we all know, there are largely two different methods, two different approaches when we want to produce unconscious effects or unconscious learning effects. We can first try to prevent the conscious perception of the stimuli, as Lena did. But also, we can try to use consciously perceptible stimuli, which are arguably stronger stimuli, but to prevent the conscious detection of the regularities, let's say, of the associations that govern the stimuli. In this sense, we can use complex noise irregularities or very complex and noisy stimulation, and also incidental exposure, in which we draw participants' attention away from the to-be-learned contingencies, regularities, associations, and so forth. One of the best known paradigms, experimental paradigms, to achieve this unconscious learning effect based on complex regularities is the artificial grammar learning task, in which in the first acquisition phase, participants are exposed to letter strings that, unknown to them, are not built randomly, are not constructed randomly, but are constructed using an artificial grammar, which is basically a very, very complex rule, a very complex regularity that participants are not instructed that is there in those stimuli. So participants' task is just to memorize the stimuli or just to transcribe the stimuli. In a subsequent test phase, participants are exposed to letter strings that are constructed from the same grammar and with strings that are constructed from a different grammar, and they have to discriminate which of the new strings follow the previously seen grammar. And what results typically show is that participants can discriminate grammatical from non-grammatical strings, even when they claim to be unconscious of the grammars. So in other words, they seem to learn these grammars largely unconsciously. Of course, not everyone agrees with this conclusion, but this is the basic story behind this task. So there can be made the following argument that these tasks which use complex regularities might be more appropriate for inducing unconscious learning effects, because it is possible, but it's partially a speculation. This has not been tested as far as I know, that this approach has a better ecological validity. In other words, we seem to implicitly learn and use in the real life complex patterns that we are not completely aware of. For instance, we seem to acquire the complex rule of the language largely without being aware of them. So we can use one's mother language grammar without being fully aware of the rules in that grammar. In contrast, it is less clear to what extent we have subliminal stimuli in the real life. A bad joke that I like to tell is that there might be subliminal stimuli, but we just can't see them in the real life. So our objective was to take this approach based on the artificial grammar learning task that uses complex structures, and to examine whether this learning of complex structures can lead to emotionally and motivationally relevant unconscious effects, such as those encountered in evaluative conditioning phenomena, in instrumental responding on or reward learning tasks, or in fully instrumental conditioning tasks, such as those that Lina presented. In the first study, focused on unconscious evaluative conditioning. What is evaluative conditioning? It basically consists in pairing an initially neutral stimulus, a conditioned stimulus, with a positive or negative unconditioned stimulus, which then might lead to evaluating the initially neutral stimulus as positive or negative in the virtue of its pairing. Now, an important question in the literature is to what extent can this evaluative conditioning effect occur without the awareness of the association? And the bulk of evidence that uses subliminal stimuli, as in the case of instrumental learning, instrumental conditioning, tends to show that this cannot happen when the stimuli are exposed subliminally. But our question was, what would happen if we use instead such complex regularities? To this end, we devised mixed artificial grammar learning and evaluative conditioning tasks, in which we exposed participants to letter strings that, unknown to them, followed one of two possible grammars. And we paired the letter strings from one grammar with positive images and the letter strings from the other grammar with negative images. And participants' task was just to try to memorize which string appeared with which image. Of course, this was impossible as there were a few hundred trials in the study. So we expected that in this phase, participants would both learn the grammars and associate each grammar with an emotion, with a positive or negative emotion. In the test phase, we presented participants with new strings from the positive and from the negative grammar, this time without images. And we asked participants to make an effective rating for each letter string. In other words, to say how much do you like or dislike this string using a Likert scale. Also, we gave them a trial by trial awareness scale in which they reported to what extent they are aware what makes the string likable, dislikable, maybe some groups, patterns of letters, or any conscious information they could possibly report. Now, the study was pre-registered, and what we found was that in about 2/3 of the trials, participants claimed to be unaware of what makes the string likable or dislikable, positive or negative. But as you might see in the graph A, even when they claim to be unaware of what makes the string likable or dislikable, they rated the novel strings that followed the previously positively conditioned grammar as being more likable, more positive than the strings that follow the negatively conditioned grammar. Of course, the effect was even stronger when they were aware of what would make those strings pleasant or unpleasant. So, in brief, what we found was that implicitly learned grammars can acquire effective valence, and they can influence effective evaluations of novel stimuli that follow those grammars. In the second study, we attempted to answer a different question, but a related one, namely to see to what extent we can rely on such non-conscious structures to behave adaptively and gain rewards and seek the rewards in our environment. Again, we developed a slightly modified version of the artificial grammar learning task, mixed reward learning and instrumental responding paradigm. In this paradigm, in the learning phase, we exposed participants to letter strings that they had to memorize. Unbeknown to them, the strings again followed one of two possible grammars, out of which we made one grammar the rewarded grammar and the other grammar the non-rewarded or the neutral grammar. And after participants memorized the string, they were presented with two possible strings and had to respond which one of the two strings is the previously memorized string. Now, they received feedback for their responses, but the feedback, unbeknown to them, was contingent of the rewarded or non-rewarded character of the grammar. So when the memorized string was constructed from the rewarded grammar, they received rewards. When the memorized string was constructed from the other non-rewarded grammar, they received nothing. They received a neutral feedback. Of course, when they responded incorrectly to that discrimination task, they received the feedback incorrect. So we expected participants to learn the grammars and also to learn that only one grammar leads to rewards. In the test phase, we presented participants with an instrumental responding task in which, on each trial, we presented participants with one string that followed the previously rewarded grammar and another string that followed the previously non-rewarded grammar. And now the task of the participants was to directly choose the string that they think would lead to rewards based on their previous experience. And after each response they made, we also probed their awareness, their level of awareness using the structural judgment attribution scale, in which participants have to respond to the question, what was the basis of your response? So in other words, what kind of information did you use when you made that response? And they can respond to this awareness measure using the option guess or random response. I just picked at random. I have no clue which string would bring the reward. I used a feeling, a conscious feeling of intuition or familiarity, but I have no idea what the basis of that feeling is. Or I used a conscious rule or an explicit memory of some information, of some fragment of the grammar, let's say. Again, this study was pre-registered. We found that almost 70% of the trials were based on unconscious knowledge or on guess or intuition or familiarity. And interestingly, we found above chance accuracy only when participants claim to use intuition or familiarity. Namely, I have a feeling, some confidence that this one would bring the reward, but I have no clue what this feeling is based on. When participants claim to be guessing, we found some bordering evidence that they were at chance. You can see the base factor bordering the conventional 0.33 threshold for no effect, for indicating no effect. And we found insensitive data regarding the conscious effect, but sensitive Bayesian evidence that the conscious effect was not stronger than the unconscious effect. So what does this study shows? That it shows that unconscious structures associated with rewards, unconscious grammars associated with rewards can guide instrumental or reward-seeking responses, but only to the extent they lead to conscious judgment, only to the extent they lead to that a conscious feeling of intuition, of confidence that this is the correct response. When they were fully unconscious in the guessing trials, they did not have above chance accuracy. Also, the fact that conscious knowledge was not better than unconscious knowledge is a rather remarkable result, which doesn't occur too often in this artificial grammar learning task. Typically, the conscious performance is way stronger than the unconscious one. Now, we pushed it a bit and we are currently doing some work on this fully instrumental conditioning phenomenon that Lina has talked about, in which participants would be required to learn more complex associations between action stimuli and their outcomes. As I said, this is a work in progress. We have some promising pilot data, and we're planning to conduct a registered report in which to test this idea. But the basic tasks is quite similar in structure with what Lina presented. Namely, participants on each trial are presented again with letter strings, and they have to conduct a go, no-go tasks. Unbeknown to them, if the string follows one of the grammars, a go response would lead to rewards. If the string follows the punished grammar, another grammar, the go response would lead to punishments. And no-go responses in both cases, in the case of both grammars, would lead to a neutral outcome. Now we would expect after several trials that participants should learn the grammars and the appropriate response to each grammar, namely that go response is the appropriate one for one grammar, and the no-go response is the appropriate one for the other grammar. Now, as I said, these are preliminary pilot data. I won't make much of them. We find some interesting results. First of all, different from the other tasks. Now, conscious knowledge constitutes the majority of the trials. So the majority of the trials are based on conscious knowledge. And even though the unconscious trials are a minority, they seem to be above chance. So participants have above chance performance in selecting the right response, the go or no go response, even when they claim to be guessing or using intuition or familiarity. Of course, again, the conscious effect it's much stronger now. So this, in our opinion, constitutes apparent evidence for the possibility of having instrumental conditioning effects based on unconscious knowledge. But we are still quite skeptical about this effect. So we have this now well-known problem of conscious contamination, which says that given the fact that any measurement, including the measurements of awareness, have some amount of noise. This is unavoidable. As a consequence, some of the trials that we classify as unconscious will actually be based on conscious knowledge, and vice versa. Some trials that we classify as conscious will be given this measurement noise classified as unconscious. Now, Zoltán Dienes and colleagues have shown that this might not be such a big problem if the proportion of conscious trials is small and the unconscious effect is strong. You can check Zoltán's YouTube tutorial on how you can assess this conscious contamination for your own design, and Lina's paper. And this was the case for the evaluative conditioning study that I presented in the beginning. We had a good unconscious effect and a small proportion of unconscious trials. Also, when conscious trials are not more accurate than the unconscious trials, which happened in the reward learning and instrumental responding study, this conscious contamination is not such a big problem, a big danger. But in this later study, on instrumental conditioning, as you can see, the conscious trials represented the majority. So in this case, this might be a big problem. What we would attempt to how we would attempt to control this conscious contamination, or to assess it, not necessarily to control it, by using multiple relatively independent, I do not claim that they are fully independent, measurements of awareness. So after each response, we would assess participants' awareness from two different perspectives. First, we plan to ask them, what was your response based on, and use the same scale with guess, intuition, and so on. And also to directly ask them, to what extent do you know which elements of the string make it bring rewards or punishments? So first, a more general question, what was the response based on? And then to ask them precisely about the structure of the strings, to what extent they are aware of the structure of the strings. Now, as I said, we plan to see what happens if we ask participants to respond to both awareness measures. Now, the general conclusions are that implicit learning of complex structures appears to support evaluative conditioning effects, adaptive responding, seeking rewards in the environment. Maybe we'll see instrumental conditioning effects. Also, this type of paradigm shows that, and this type of studies show that it is possible that these unconscious effects appear only when unconscious structures lead to conscious judgments, when you have that conscious feeling that this is the right response, although you might not be aware of its basis. We've actually found that in the instrumental responding reward learning study. We did not test that in the evaluative conditioning study. It remains to be determined in the instrumental conditioning study. But I want to mention that there is evidence that not unconscious effects based on these complex structures actually require conscious judgments. Ryan and Zoltán have some studies showing that even when participants claim to be fully guessing, they can also proceed with above chance accuracy, but not in this sort of conditioning. Thus, this has not been tested yet or shown yet. Okay, so I would like to thank my colleagues, my collaborators with whom I've been discussing and working on this idea, Andrei, Adrian, Zoltán, and Lina. And if you are interested to read the paper, the evaluative conditioning study and the instrumental responding reward learning study, you can see their citations there. Okay, thank you very much for your attention.
Thank you. That's fabulous. Okay, questions? Anyone stick a hand up? Well, I'll kind of.
I see a question there.
Can't see.
Hey, thanks. So the classic Reber 67 paper, right?
Yeah.
It's like you're doing this artificial grammar learning. You ask participants, hey, how are you performing so well above chance? And they're like, I have no idea, right? No subjectiveness. But then you're saying, you know, in at least your study too, that the guessers were below chance.
Yeah.
So how do you, why aren't you showing that above chance guessing effect, or what's the difference in your paradigm, I guess?
Well, in my paradigm, participants, guessers or the trials based on guessing were not above chance, but those based on conscious feelings of intuition and familiarity that participants could not further justify. That, according to DNS and Scott's theory and measurement, still constitutes evidence for implicit learning. In this type of trials, participants were above chance.
So maybe the thing that your study has is this like remember no paradigm in addition to the guess, and maybe that's why that's the discrepancy.
Yeah, this is a kind of knowing, saying that you use intuition or familiarity. I know, but I don't know how I know. So it's I think along those lines of the remember no paradigm.
I think we can add to that actually as well. Some of the work we did, in part, I think some of those early studies, they didn't look at trying to ascertain what the source of the knowledge was. Those attribution judgments there saying it was memory, it was a rule, and so on. They weren't being used. So people were just saying, oh, it's that, yeah, I don't know what the basis was. But actually, when you look into the detail, as was being demonstrated here again, people have a conscious feeling, say a familiarity, but they don't have conscious structural knowledge of the grammar. And that's really what we found. And we obviously hadn't applied it to instrumental conditioning, which is fascinating to see. It's lovely to see those results. But that's really, I think, the difference between the original REBA and this and the work that we did as well. Essentially, we're saying, yes, your structural knowledge is unconscious, but your judgment knowledge, you've got that by virtue of familiarity or some other signal that is experienced consciously. Okay. Questions? Yep.
I hesitate to ask this because it's really general, but since no one else was asking, so I'm going to ask it, which is, why think that this is consciousness as opposed to just conceptual? And so, you know, what the people seem to not get is the concepts. They don't understand the rules, but they don't lack consciousness at all. They're consciously looking at the streams and seeing the streams the whole time. And so I wonder why call it conscious and unconscious as opposed to they understand or they don't understand what they're doing and how they're doing it.
Okay, I think that the question here is conscious of what? They are, as you said, clearly conscious of the stimuli, but what we are trying to assess is to what extent they are aware of the contents in their memory that influence their responses, that they base their responses on. So it is a sort of consciousness about their contents from their memory, not consciousness regarding what they are seeing in that moment. So here I think that consciousness might be put into the discussion, introduced in the discussion.
I might be repeating what we've already said, but thinking of how you would describe how you make a decision. Thank you. So thinking how you describe how you make a decision in an artificial grammar learning design, I think that is hard to put it in words. So it could be that you are sort of aware of what you did, but you cannot really express it in a way that you can respond to the question.
Yes, that's a very good and very complicated question, because we are indeed using the capacity to verbalize, to communicate as an index of awareness here. And this has some theoretical support. The global workspace theory would say that you need to have some global access, and this also means that you, in principle, you might be able to put it in words. So yes, it is based on participants, and it is limited by participants' capacity to report what they are aware of. Their introspective abilities might interfere and limit the granularity of this measurement, but it is a limitation that we acknowledge and chose to live with, because any awareness measurement you would use, you would have some limitations that you just need to put up with. So
Thank you.
yeah, thanks.
Okay. One final question, anybody? Otherwise, we'll move on. Okay. Thank you very much.
Thank you. Thank you.
Right. Very much. Oh,
Yeah.
oh, that's useful. Very much looking forward to this talk because it relates very much to some of the work we've done as well. So that's out of the way. We have Gaten Mertens presenting a critical assessment of the evidence for contingency of unaware fear conditioning, methodological and literature-wide problems. Okay.
So, thank you very much. It's really an honor to be here and to present my work. I'm very excited, a little bit nervous, but I hope that will be in my favor. So I would like to say something about contingency awareness and fear conditioning and some of the problems with this literature. Let's see, it's already going wrong. Yes. So some definitions I quickly looked up on the internet, and what is often striking is that I think in popular consciousness, fear conditioning, so that's pairing an initially neutral event with something aversive that can lead to conditioned fear responses. For instance, an example I often give in my classes is you are not afraid of dogs, but at some point you get bitten by a dog, and as a consequence, next time you see a dog, you are conditioned to be afraid of. Or you go to the dentist, you're not really afraid of the dentist, but then you undergo a very painful procedure, and next you have conditioned responses, you're afraid of going to the dentist. And this phenomenon has often been studied in animals and in humans, often with more abstract stimuli, for instance, like just geometric faces, geometric shapes, something very arbitrary are paired with electric shock, and that often leads to conditioned fearful responses. And in some of these definitions on fear conditioning, for instance, it's said that it's discovered by Russian physiologist Ivan Pavlov. Classical conditioning is a type of unconscious or automatic learning. The same in some of the other definitions, it's automatic, unconscious, automatic, unconscious. So it's often presumed to happen in the absence of consciousness, very automatic. So that's the way we often look at fear conditioning. So these were some definitions from popular websites, but also this paper by Minneke and Oman. They introduced the idea of an unconscious fear module. This paper has been cited over 4,000 times, so it's very influential. And there, the fear module, which is centered on the amygdala, is assumed to show the following characteristics. One of it is encapsulation or resistance to unconscious cognitive influences, because the basics of fear and fear learning evolved before the emergence of conscious thought and language. So again, the idea is that fear conditioning can happen in the absence of conscious awareness. So just some clarifications. On the one hand, I'm talking about fear. So one definition is fear is an emotion in response of perceiving or recognizing a danger or threat, and it may produce behavioral reactions such as aggressive responses or fleeing, so fight or flight. And then learning, those are changes in the behavior of an organism that are the result of regularities in the environment. Fear conditioning, as I said, it refers to a broad range of techniques whereby initially neutral stimulus comes to elicit fear responses because of being paired with an aversive event or events. But once again, I want to emphasize what's often assumed is that both of these processes or phenomena, they're evolutionary preserved adaptations that help the organism to survive by avoiding danger and by adapting to the environment. And they're often assumed to operate pre-consciously and automatically. So I hope I convinced you that a very general idea is that fear conditioning is a very fundamental process that can operate in the absence of conscious awareness. It's often summarized in this debate between single process and dual process theories. In single process theories, the idea is that first should be actually conscious knowledge, which results in learning, and then as a result, there is a conditioned response. So according to this view, people are actually learning and awareness, they co-occur, they always co-occur, and they lead to conditioned responses. But according to dual process models, which inspired a lot of fear conditioning research, you can learn in parallel to either learn conscious or regularities in a conscious way in declarative memory, and then you have verbalizable knowledge, or you can also learn it unconsciously. For instance, through the amygdala, which happens unconsciously, it produces a conditioned response, but it does not require conscious knowledge or verbalization. So you have these two theories, and especially the latter one influenced a lot of this research. Just some references if you're curious to read up more about it. And this has been a very long debate. So already one of the earliest paper I found, but I think it goes back even further, was from 1937. First paper introducing the idea of that conditioning can happen unconsciously. And it's essentially, so it is definitely not all papers, but it's been going on for at least 80 years, maybe more. So that's a timeline of relevant studies. And maybe a bit repetitive because, of course, Lina and Rasman already introduced a lot of these ideas. But fear conditioning paradigm essentially looks something like this. For instance, you have a blue square, it gets paired with an electric shock. You have an orange circle, it's not get paired with an electric shock. That happens repeatedly. So you do that with humans. You can also do it with rats. It's a very broad paradigm, broadly applied. Often the stimulus that is paired with the electric shock is called the CS plus, the conditioned stimulus that's followed by the shock. And the control stimulus is the CS minus. So that's just some useful terminology to keep in mind. And a very common outcome measure is a skin conductance response. So whenever people are a bit aroused or a bit scared, you see a typical peak in skin conductance after about 1 second, and it stays there for about 3-4 seconds, and it goes down again, which you can measure as a conditioned response in this paradigm. And then you get these nice learning graphs that we already seen before. And then this difference between CS plus and CS minus, you take as a conditioned response. Just so you have an idea of how these procedures look like. And what happens in these unaware versions is that they typically, often, I think most often, they try to mask the CSs by making them harder to perceive. For instance, by backward masking or some other procedure, to mask the pairings or the contingency between the CS and the US, so the CS and the electric shock. What I find something interesting to note here is that typically you see that they try to mask either the CS or the pairing between the CS and the US, but they never try to mask the US, never try to mask like the electric shock or the sound or the noise or whatever is being used. Which is, I find interesting. It could be an option, right? If you're interested in unconscious learning, you could also try to mask the US, but that's never been done. Why? I think that's maybe already alludes to my conclusion, but this is something very relevant to us as humans, as US should be. So it's really hard to preclude conscious awareness of something that's very relevant to you. And if you try to decrease the intensity, to make it imperceptible, then the conditioning will probably not work. But so in general, we try to mask the CS to study unconscious conditioning effects. So masking the CS already, so backward masking we already saw also in the talk of Lina. Sorry, Lina's a bit flustered. There are some other ways, binocular rivalry, adding more stimuli to distract the contingency. These Gabor patches are also sometimes used where this very subtle change in the direction of these gratings or in the frequency of these gratings. So you try to make the CS very subtle. That's one way. Another way is to try and distract your participants, so you can do a demanding task, a two-back task, whereby participants need to remember something presented 2 trials before, or a spatial cueing task where there are a lot of different stimuli and there's a subtle relationship between the CS and US. And the final way is just natural variation between participants. I think everybody who did behavioral experiments with participants knows that people are sometimes distracted. Sometimes they're not paying attention and they fail to remember the contingency. So there are different ways of trying to mask the relationship between the CS and the US. So now my study, what did I do? So I was interested in this phenomenon. And I did a systematic review and meta-analysis. I mostly snowballed through literature reviews and relevant publications to compile a list of 41 studies that looked into this. From 30 of these studies, we were able to extract the necessary statistics to conduct a meta-analysis. So we did a systematic review on 41 studies and meta-analysis on 30 studies. And some overall figures from this review. So the median sample size of these studies was 18. Most of the time, the studies used skin conductance response as the conditioned response or the fear response that I looked at. A shock was most used as an unconditioned stimulus. And most of these studies, they used a post-experimental questionnaire to ask for awareness, if people were aware of the CS-US contingency. And this is the forest plot. So this is the effect sizes. I ranked them according to the how big the effect size was from all these studies. And what came out of that was that on average there was a ASSC of 0.49. So let's say medium effect size. So based on just the meta-analysis, it seems that there is a robust effect of unconscious conditioning. So this is really focused on conditioning in unaware participants or unaware trials that we selected, and on average you get an effect size of about 0.5, which is medium. But then we looked at a funnel plot. So as we know, there's often bias in the literature. There can be publication bias, and a funnel plot is one way to look at it. And the idea is here that you plot the effect size of studies against their standard error. And if there would be no publication bias at all, you would see these nice pyramids, as these lines indicate that the more accurate studies, they would gravitate in the top towards an exact effect size estimate. And then there would be a very nice symmetrical pyramid. But what we actually see is that these black dots are imputed studies, are observed studies, and the white dots are imputed studies. So actually only the black dots are actual studies. So there was quite a lot of publication bias, and according to some of these tests, 10 studies needed to be imputed to correct for publication bias. And if you do that, so first we have the Eggers test for publication bias was significant. The adjusted ASSC was about 0.3, so already a bit smaller than the previous estimate. So indicating there's publication bias, and it leads to inflation of the effect size. We also did another analysis to look at publication bias, and that was a P-curve analysis. I don't know if you're familiar with it, but with this type of analysis, you essentially you look at all the significant p-values in the literature, so all p-values below 0.5. And we know if, for instance, if the null hypothesis is true, then all p-values below 0.5 and just all p-values, regardless, they should form a uniform distribution. So every p-value would be equally probable. Then you get this red line here, this dotted red line. If there is a true effect, you would expect more very small p-values rather than p-values around 0.04, 0.05. Because if there's true effect, that is the expected distribution of the p-values. And then what you would expect in a, oh, that's already going very fast, but if there's a lot of publication bias, we would expect a lot of p-values just below 0.05. Because people try to p-hack, but they don't bother to do it very well. So a lot of these p-values should be right under 0.05. And that's actually what we see. We see that there's a lot of p-values there. There are also some p-values quite small, but we will see some alternative explanations for those. But so the test of flatness was actually significant, and there seems to be also with this test publication bias in this literature. So intermediate study, a lot of studies have investigated unaware fear conditioning. A lot of times visual CSs are used and the shock as a US. Skin conductance is used as an outcome measure a lot. Meta-analysis shows a small to medium effect, but there is good evidence for publication bias. Then we looked into some other problems. I'll go through them quite quickly because they've already been covered, and I don't have a lot of time, which is the main reason why I'm going quickly. But one problem is that often masking is not very successful. We often try to have the CSs at just a perceptual threshold. For instance, backward masking is often used techniques to try and mask stimuli, and one often used parameter is 30 milliseconds to present the CS, and then it gets masked, for instance, with another phase or with a neutral pattern or something like that. But based on a lot of later work, we actually know that's another good parameter. Luis Pessoa looked into this. About 20% of people become aware using this type of parameter. And similar problem exists with other types of masking procedures. Often they're not really good, and often some people become aware, as we saw already in the previous talks. So what we need to do is also measure awareness. That's another problem. But also measuring awareness is really difficult. Why? So as we saw, we often use post-experimental questionnaires, but what happens there is people are asked at the end of the experiment, do you know the rule, or did you notice a regularity? And by then people may have forgotten that there was a regularity just because of passage of time. Also, it's an underpowered test. There's just one trial to ask for awareness, whereas there were maybe 10 or 20 trials to assess conditioning. It might be irrelevant. Maybe people have to identify the phase that was used as a CS, but maybe people are using other type of information to distinguish between the CS plus and CS minus, maybe the amount of hair or something like that. And the criteria might be too lenient, that actually people that are classified as unaware with the criteria are actually aware of the contingency. And so this has been touched upon before. There's also a problem of regression to the mean, described by, among others, David Shanks. And that classifying people as unaware is a type of extreme group selection. And as a result, you might expect, you will expect a regression to the mean on the conditioning outcome. But I'll just skip over this now because it's already been covered and for the sake of time. Another problem is that there's a lot of choices that have to be made, a lot of researchers' degree of freedom. This figure displays the amount of ways you can analyze skin conductance responses. There are a lot of choices to be made. For instance, what trials to analyze, how to quantify your conditioned response, the selection of different outcome measures you may have taken into your study. For instance, rating, skin conductance, starter response, heart rate. Exclusion of trials and participants. So there are a lot of decisions to be made in your experiment, which can influence your results. So this is, thank you. These are researchers' degrees of freedom, and we know that these can inflate the chances of finding spurious results. And then finally, a problem is that often pseudo-random orders are used, where maximally 2 of the same type of CS can be followed by each other to avoid very long sequences of the same CSs, because that often introduces all kind of cognitive biases like gambler's fallacy and so forth. So in fear conditioning, we try to pseudo-randomize our trials, but this leads that you can identify or know when a shock will be given, even if you can't consciously perceive the CSs. You can just use a simple rule, like after every trial where there's no US, the next trial there will be a US. And that allows you to, above chance, predict when there will be a US. So I just highlighted from this sequence I generated how many trials you could predict. So those are 4 problems. What we did is we coded the presence of these problems in the studies we included in our systematic review. And what we found is that actually most of the studies that found evidence for unaware fear conditioning were methodologically weaker. So there seems to be a bias in the literature that the evidence for unaware fear conditioning is mostly based on methodologically weaker studies. So given that I run out of time, there are literature-wide problems in this field. So small samples, publication bias. There are methodological problems that have been covered by some of the other speakers. Masking problems, awareness assessment, researcher degrees of freedom, and trial order effects that compromise the evidence. And future work should really focus on pre-registration, trial-by-trial measurement of awareness, and some other things. But currently, there is no convincing evidence for continuously aware fear conditioning. If you want to read more on this study, this is a publication on this work. And I would like to thank you for your attention, and feel free to ask any questions.
Fabulous, thank you. Okay, questions? So David was quick in there. Thanks, that's a really nice meta-analysis. So you told us about 2 methods for identifying publication bias, the trim and fill and P-curve. Finding evidence of publication bias is quite a sort of weak thing to do. I mean, publication bias is everywhere. A sort of stronger test is to use methods to estimate the meta-analytic effect when you correct for the publication bias that you find. And I wonder whether you've used any of the modern techniques for doing that. I mean, there's a technique that has been developed in the last couple of years called robust Bayesian meta-analysis, which has been shown to be extremely effective. And it might be quite interesting to see what the adjusted effect size estimate is, because it might actually be positive despite the publication bias.
Okay, yeah, thank you, David, for this question. It's a very good suggestion. I'm not really an expert in meta-analysis, so I did really the basic things. There's a lot of developments in this area, and I agree with you. Like a better test, more modern test for publication bias would be good, and to try and correct for it, that would give much more information. And maybe I should check. In Tilburg, there are a lot of people very well versed in meta-analysis, so maybe I have to check with them, because frankly, I'm not a great meta-analyst. So, but yeah, it's already interesting that even with very crude measures, you can clearly see the publication bias. So for me, that was already a nice finding. But yeah, that would be a very good suggestion. Thank you.
Hey, thank you for the talk. I think that is super interesting when people show this type of meta-analysis to have a general overview of a field. And I wanted to ask how exhaustive was the search of publications, because I thought that there would be more, given that is, I thought that the literature would be bigger.
Yes, good question. One thing I didn't mention, just because there's not so much time, is I limited publications until 1970. So everything published after that. But I know there are publications before 1970. But the problem in this literature or in this older publication is often they don't even give like t-test statistics, or it's very hard to extract any information from these very old publications. Otherwise, yeah, I tried to quite extensively look. I think I discovered most of the publications. Also, we had very good reviewers that looked at this publication, and they didn't give any additional suggestions. So I also thought there would be a bit more, but I haven't found them yet. But if you have, if you know of any.
No, it's a field that I really don't know, but I thought that there would be more because it's just so well known, the effect that.
Yeah, that's maybe the surprising thing, that it's very common knowledge. It's in a lot of textbooks, this idea, but it's actually based on, still 40 studies, but not that many. Yeah, thank you.
Perhaps one last question, anyone?
Thanks for your talk. I think you mentioned something about one of the methodological challenge is the measurement of awareness that you mentioned that they are asked after the experiment, and you mean that there's some memory load maybe, but like I think one of the other method is to do a trial-wise measurement, but like one concern about the trial-wise method is that maybe you emphasize and direct the attention of the participants to the stimulus that you want them to be unaware of. So do you think that you will make the so-called unconscious stimuli more conscious to the participant? And
Yeah, exactly. Well, actually, two previous talks, they use trial-by-trial measurements, and it's possible to still have a mass stimulus, even if you do the trial-by-trial measurement. So yeah, actually, those were already much more advanced studies. But yeah, it's the case if you direct people's attention to the contingency or to the stimuli, they're more inclined to detect it, which is an interesting finding by itself. But it seems to be possible, and it's a much more sensitive way to assess awareness than asking people at the very end of the study, oh, did you notice a regularity? That's quite insensitive test. So we already know that this is. This misclassifies people as unaware. But indeed, if you direct people's attention to the contingencies, they are more likely to identify them. Yeah. All right. Thanks.
Thank you very much. So we have just the one talk left by Professor Eva Jablonka, sorry, and she's joining us via Zoom. So we just have a quick switch over.
Okay, do you hear me, Pete?
We can hear you, Eva. We just can't see your talk yet. So
You cannot hear me?
yes, we can hear you. Can you hear me?
Yes, I can.
Great.
And can you see me? I see myself.
Are we sharing? Yeah, we are.
So
Right,
one second. We'll just get the screen ready for you. 1 second. We have to stop our share, and then you're in a position to share. Great.
Okay.
Minimize. One second. Yeah. And if you would want to put your screen into presenter view, and then we're there.
Okay, fine. Thank you very much. So I'm going to talk about a theory developed by myself and by Simona Ginsburg with the help of many, many people, students and colleagues, about the relationship, the evolutionary relationship between the evolution of learning and the evolution of consciousness. And I'm going to focus, if I will have time, about some of the implications and predictions of this theory. So first of all, this work was mainly done with Simona Ginsburg, and the pictures that you will see are by Anna Zhligovsky. Now, just to be clear about what I'm going to talk about, when I'm talking about sentience, I'm talking about the process of having private, subjective, coherent experiences, including perceiving the world in the here and now, seeing red, smelling jasmine, and so on, feeling, having experiences, and also having feelings of virtual realities from a point of all from a point of view, which are felt to be owned by the animal. There is great variability in the range and the richness of perception. Now, the kind of consciousness that I'm going to focus on is minimal consciousness that does not include the experiencing of virtual realities or the awareness of the processes that lead to the experiencing of to the feelings and to the and to perceptions. So I focus on minimal biological consciousness. And when we started thinking about the evolution of consciousness and how we could think about consciousness from this perspective, it was obviously, as we all know, very, very difficult problem. And we were trying to find some kind of way of approaching this problem and to do that, we looked for something which was somewhat conceptually similar, such as how people were trying to understand the origin of life. So we tried to understand the origin of consciousness, the evolutionary origin of consciousness, by drawing on research or methodologies that were developed in research on the origin of life. And we adopted a methodology that was employed by a Hungarian chemist, Tibor Ganti, when he was studying the evolutionary origin of life. And what he did was basically, he looked at the literature on the origin of life, the best literature available to him, and he compiled a list of capacities that are minimally sufficient for characterizing a mode of being as living, in his case. And then he specified the relationships between these capacities. And he built a little toy model that showed this relationship. And then what he did was to identify one property or one capacity such that when you find evidence of it, you have evidence that the major evolutionary transition, in his case, from non-living organisms to living organisms, has gone to completion. And we call this the transition evolutionary marker, this kind of marker for a transition that has gone to completion. And this evolution, if you find such evolutionary marker, it allows you to reverse engineer the system that enables it. And in this way, you can also understand the system dynamics. So for him, the evolutionary transition marker for life was unlimited heredity, the ability to have hereditary variation, that a number of hereditary variation that is much, much, much larger than any individual or any lineage of individual can ever experience in its lifetime. In its lifetime, much, much greater than the range of environments that an organism can meet. So the basic idea is here. We have a list. We find a list of capacities. This list of capacities is minimally sufficient to characterize a mode of being, a particular mode of being, living, minimal consciousness, or minimal rationality, if you're interested in this. And then you find also one particular capacity, which once it is in place, it requires that the whole list is in place. And this capacity marks the presence of the mode of being of interest. For Ganti, it was life. For us, it was consciousness. Now, so what we started doing was trying to look at the literature from psychology, from neuroscience, from cognitive psychology, from philosophy of mind, from anything we could find, and find some kind of list of capacities that would satisfy most people, of course not all people, that if you find such a being that satisfies this, that has these capacities, for example, on another planet, you would sort of regard this being as plausibly conscious. So the list of capacities include binding and unification, perceiving an apple as a coherent whole, as green, round, smooth, and so on. Some kind of global accessibility and broadcast, that there must be some kind of integration among sensory, motor, memory, and value subsystem that enable generalizations, discriminations, and other such operations. some processes of selective amplification and exclusion, for example, those that lead to the selection, shift, and maintenance of attention. Something like mapping, or what philosophers call intentionality, mappings of body, world, action, and their relationship, which enable predictions, some prediction in terms of action of the future. Some temporal integration, so that the presence is not an infinitely small intersection between past and future, but it has some kind of duration. There's temporal thickness, working memory, for example, extended past future kind of essence. There must be a flexible evaluative system and goals, goal-directed behavior based on representations of learned predictive relations about actions, outcomes, rewards, and all these are anchored in past and present prioritized physiological and context and present needs and past needs. And some kind of agential embodiment, implementation in a proactive body with object-oriented spatial cognition that requires some degrees of freedom of movement and perception and their control. Some kind of, and this is very much associated with inherent privacy. And self-other distinction, which has always some kind of stable perspective, a sense of body ownership, a sense of being. Now, all these capacities are quite demanding and are partially overlapping. And we extracted them from the literature, from very different different sources, and we think that this and nevertheless we find quite a lot of overlap between these very different sources. And I think that this is a very comprehensive, maybe too a comprehensive set, maybe too demanding in some ways. We are not sure, but this is the list of capacities we came to. And then we looked for something that can be a good marker that requires that all these capacities are in place. So we didn't start with trying to connect all these capacities together and build a model. We started by trying to find the marker, the evolutionary transition marker, that will require that all of them are in place. And that is because it is very difficult to create a model like the Ganti's model of minimal life for minimal consciousness. So we thought we will go around it by trying to find the marker and then doing a model of the marker. So what we did, so after a lot of work and a lot of problems and a lot of false starts, we came to something that we called, inspired by Ganti and by Maynard Smith and Satmary, work on the origin of life, which we called unlimited associative learning, as a marker of minimal consciousness, that requires that all the traits that I was showing you before are in place. And this can be operationalized by mainly by four, and we operationalized it with four different learning capacities. One is discrimination learning, the distinction among novel composite patterns of stimuli and action ability. And so the animal can discriminate, for example, discriminate between more or less desirable mates, learn different routes leading to food and shelter, etc. This is one, discrimination learning. Second, it can learn even if there is a time gap between the neutral and the complex stimulus and the reinforcement, this trace conditioning. The third is that it can do trade-offs, and and the value of a learned pattern can be flexibly changed. So there is a flexible value system. And the fourth is a second order learning. So you learn something, and on the basis of what you have learned, you can learn something else. And we said that if all these four capacities are in place, there is a good, they require that all the capacity that we were talking about before are in place. So here is the same diagram, but this time with this, specifying the particular list that we have compiled. And the transition marker is our unlimited associative learning capacity. Now, the reason that we thought it was a good capacity, that it was a good marker, was because this kind of learning requires integration of sensory features of information to form coherent wholes, coherent configuration of the world, of the body, of the action, of their relationship, and enables discrimination among patterns as well as generalization and transfer. Second, it requires in a finite system hierarchical and recurrent mapping of world, body, and action into updatable representations of the world, of the body and the game, and their interactions. It needs exclusion of irrelevant signals and focusing mechanisms, which is obvious because the noise, the amount of input we get is huge all the time, and we all the time need this kind of focusing, this kind of and exclusion. It needs a dedicated memory system that stores event representations, not just parts, but also wholes. So we need something like a proto-declarative system. We need an evaluation system that assigns valence to any compound input configuration and very importantly, enables context-sensitive prioritization. So the ability to prioritize different stimuli in real time. So, and the ability to distinguish between body-generated and well-generated stimuli, and the ability to distinguish between learned action outcome contingency and identical outcomes that are independent of one's actions. All these things are required for the kind of learning that we have been talking about. Otherwise, it just would collapse. Now, we made a small model. This is a toy model. This is not a computational model. This is just something just to show the relationship between different kind of units, and between different kinds of units that can support the kind of integration that we require. So we need sensory motor units. We need integrative reinforcement units. We need the kind of memory system that we have been talking about, and we need integrative motor units where action is represented. And all this have to come together. And this is just showing us in a very, very general and schematic and simplistic way the kind of interactions that are happening during the kind of associative learning that we're interested in, without showing, of course, all the complexities, all the hierarchical, sequential hierarchical integrations that must occur in such a system. It is not a computational model. We have done more complex model than this, but it is still not a computational model, and this is something that has to be done and has to be and would add a lot to the kind of work on and the kind of ideas that we have, also test them to some extent. Now, it's a very, as I said, it's a very general descriptive model of the evolutionary marker that is required for biological implementation of minimal consciousness. This particular model is not committed to a particular neural implementation, but it is committed to a particular functional, dynamic, embodied architecture. And what it enables, what unlimited associative learning enables, it enables goal-directed behavior that involves recognition of predictive relations between composites, sensory inputs, action patterns, outcomes, and rewards. And this leads us to the very difficult question of the function of consciousness. Because if unlimited associative learning is indeed a marker of consciousness, then the function of consciousness is to create a new realm of goals. It enables organisms to make flexible, context-dependent decisions and reach goals that are based on composite, learned predictive perceptions and action outcomes, motivation, and past and present effects that otherwise they just would not recognize as such. And this very much is in line with what William James said, that consciousness is a fighter for ends, of which many, but for its presence, would not be ends at all. And here what you see are two flowers. One is wind-pollinated flowers that is white, doesn't have any colors, no color patterns. The nectar is tasteless, it doesn't have sugar. It's very simple, and it is only wind-pollinated. And the other one is pollinated by insects. In this case, we show a dragonfly, and it has a lot of patterns. And the reason is that the dragonfly can recognize the difference between patterns. The wind cannot. It can recognize differences between different colors, between different patterns, and choose the pattern that is more indicative of nectar, which is, in this case, full of sugar and full of nutrients. So the ability to recognize, to make this discrimination is one of the things that consciousness enables. And it has, of course, an enormously important adaptive value. Now, what we did, what we then did was to look at the distribution of unlimited associative learning and the proxies of this kind of learning in different groups. So we looked at the learning literature of the last 150 years, and we didn't, of course, cover it all, but we tried to cover as much as we could, because writing the book, the original book, took us 12 years. A lot of it was devoted to this kind of research, and we found that unlimited associative learning or its proxies can be found in most of the vertebrates that have been researched, in all the vertebrates that have been researched, in some arthropods, and in the colloid cephalopods. In other cases, we found partial evidence, very partial evidence. I must say that there are groups that have been very poorly researched, and all we can say is something positive. We can say who has this unlimited associative learning and who, by inferring from this, is minimally conscious. We cannot say who is not conscious. It's only a positive kind of marker, but nevertheless, it's something. And then we looked at the brains. If you have this kind of capacities, you have to have the kind of brain, the brain regions, the brain processes that support them. So we looked at mammals, we looked at insects, and we looked at the colloid cephalopods, and we looked for the structures that support the kind of units that must exist in order to implement unlimited associative learning, the integrating sensory units, motor units, memory units, reinforcement units. So we looked at them, and we found that they do exist indeed in some of the arthropods, in all the vertebrates, and in the colloid cephalopods. And here is just it's an interesting.
Eva, can I give you a few minute warning just to wrap up in the next few minutes? Yeah.
Okay. Okay. So I will jump on that. We found out that it was that in two groups, the vertebrates and the arthropods, this kind of structures from fossil evidence appeared. Fossil evidence of brains appeared in the Cambrian, and in the colloid cephalopods, the structures appeared later on. And we suggested that unlimited associative learning and minimal consciousness not only appeared first during the Cambrian in these two groups, the vertebrates and some arthropods, but was also the adaptability driver of the Cambrian explosion. Because of its incredible adaptability, it led to antagonistic and cooperative arm races and feedbacks that led to an evolutionary explosion. So there are many, many testable predictions that follow this this model. We have 22 of them. I don't have time to go through them. Some of them have a lot to do with the kind of evidence that has been given here for the ability for some unconscious associative learning occurring, but not the kind of unlimited associative. We claim that unlimited associative learning cannot occur unconsciously. And this is just one, and I think that there is increasing evidence for that in increasing number of studies that support this kind of conclusion. But this is just one of the conclusions that one of the predictions that we had, and it seems to be sort of to carry some weight. So I just want to go to, since I do not have time and I cannot talk to you about everything, I would like just to say that of course consciousness did not evolve further. It is first of all very variable, and it has become enriched in many. It has become enriched in the evolution of some lineages. There is something like imaginative consciousness, which is consciousness of the past, actual consciousness and feelings of what happened in the past, and of future possibilities. Both of these things in some animals can be conscious, and of course, in our case, we can have also the kind of symbolic consciousness that is very, very human specific. And I want to thank you for hearing me.
Thank you. Just 1 second before I get to ask questions. I'd like to try and see if we can. Can you switch it up so that we can just see her image? That'd be great. questions? Yeah.
Thanks. I heard, so that was super interesting. I heard two things that I'm trying to reconcile. And so I may not have fully got everything. So maybe you can help me. So there was the slide with the James quotation and the thought about maybe the evolutionary function of consciousness is something like setting novel goals, right? Consciousness, this is the one where you have like consciousness is a fighter for ends, right?
That's right.
But then, so in the first slide where you were talking about the sense of consciousness at play, I understood you to be saying we're talking about conscious awareness, but not, I think you called it virtual experience. So like awareness of things that aren't present right here and now. And I got that impression at the end as well, where you were talking about further, right? There could be further evolution where, you know, we talk about the evolution of imagination, consciousness of things that are not present now. So I guess my question is, how can there be, you know, novel goals that are generated by consciousness where those goals are present here and now, right? If I have a goal of navigating across campus to another building, right? I'm thinking of something that's not present here and now, right? Or
yes, your experience of wanting to do something or choosing or something like that is based on past experience usually, or on some innate scaffolds that you have, right? Which are based on evolutionary kind of learning. But the experience is always in the here and now. Even if you experience, for example, sadness about the death of a partner or somebody dear to you, then it is always in the here and now that you experience this kind of thing. What I'm showing, what we see in this, what I'm trying to say is that unlimited associative learning allowed organisms to seek very complex goals that otherwise would not be perceived for them, would not be appreciated as goals at all, to learn in this kind of way. Now, this dragonfly or birds or mammals that lead, that, for example, if you think about sexual selection, the selection of very complex patterns of the songs or of visual patterns, if you're thinking about this, these are obviously due to the ability, to the discriminatory ability of the female in most cases. Some cases it's the male, sometimes it's both. And this discriminatory ability is, we say, the outcome of the evolution of associative learning, of unlimited associative learning. Now, if you have the machinery for associative learning, you see things as composite wholes, and you're able to discriminate between them. Otherwise, you just don't see them as such. You cannot do the synthesis and analysis that is required for discrimination. This is one of the things that unlimited associative learning allowed, and that is one of the marks. And we say that without consciousness, without minimal consciousness like this, you would not have these complex patterns in the world. That they just wouldn't exist, because there would not be nobody would be able to select for them. And the ability to select for them is the outcome of the evolution of this type of learning. I hope this makes it a little bit more clear.
Thank you. Other questions? Yep. Sorry.
Thank you very much. Very interesting talk. A couple of things I'd like to hear some clarification on. One is, could you speak a little bit more about the biological implementation of this UAL? How's this happening? Maybe if you could talk about some of the learning mechanisms in the brain. And the second thing I'm curious about is distinguishing the UAL from other theories about decoupling and how decoupling allowed for the mind to do all these new things.
Yes, thank you. So some of the slides I didn't show you is our exact. We're with my student Oriane Zaks, who will talk more about it, I hope, on the 25th. We have been trying to look at different theories of consciousness and compare it to our own consciousness, and to see also to look also at the implementations at the neural level and also at the behavioral level. And although the GNW model was developed in humans and requires verbal kind of some, according to not in recent years, they were also talking about the GNW occurring without verbal ability in other mammals, but originally it was developed for the human case. But basically, the basic structure of the GNW model and our model is very similar in the sense that the same kind of units are required and things must come together in order to create the kind of integration that leads to consciousness. And both of these models have very specific predictions and assumptions about the neural implementation that is required. Now, what we did was to look at the fish, basal fish, at the very early invertebrates, and to look at the assumptions of the GNW model, for example, having a bottleneck, for example, having some form of ignition, for example, the coming together of all this kind of different kinds of types of hierarchically integrating units, their information processing coming together, and so on. And what we found, much to our surprise, was that the GNW in fish, although of course it was not developed for fish, is actually implemented in the hippocampus homologue. So that the hippocampus homologue, which is doing the kind of declarative kind of memory system, very simply, relatively simply in fish, it evolves very much further in the vertebrate lineage, has a dual role. It is both a memory system and a GNW at the same time, something we did not expect, but this is what we found. And this also made us actually change our model to some extent. In order to accommodate this information, we, in the case of fish, we have to change the model, and also the GNW model, if you apply it to fish, has to be changed to accommodate this very interesting and very speculative at this point to some extent. I mean, we did our best, but of course more work will need to be done. This finding. So it's a simpler kind of model where you have a central association unit, which is also it has a dual role, both as a central association unit and as a memory unit. And we think that this kind of work has to be done in. We have to specify, to look for the processes that we require, and and where they're implemented in the brain in different lineages, because we cannot take for granted the general model is simply too general. We'll have to do it also for the invertebrates that we think are minimally conscious, and it would be very interesting to see how these types of integration that we are requiring and the types of feedbacks that we are requiring are actually happening in different lineages.
Thanks, Eva. We've got one more question and then we'll have the general question session.
Hello, Eva. Ralph Lewis here. So nice to have you share your insights at this conference. Eva, regarding that previous question about about imagination and the ability to project goals when really we're only perceiving things in the here and now. Perhaps is the key word here combinatorial? I can't remember, I think you may have used this word or you've certainly implied it. It's the combinatorial complexity that consciousness makes possible, that is probably not possible with unconscious processes. That it may be key to why consciousness is so adaptive and enables this almost infinite imagination.
Yes, I think so. I think, you know, if you have the ability to imagine is another very big leap in the evolution of cognition. It's an end of consciousness. I think it really allows, it's like a major transition in the evolution of cognition, precisely because of what you say, because it allows for this combinatorial thing, it allows planning. And planning is not possible with real planning, I mean, you know, to planning which is context sensitive, is not possible without some form of imagination and the usage of this combinatorial ability based, of course, on past episodic-like memories.
Thank you, Eva. If you can stay there, because we're going to have a general question session. I just wanted to very briefly provide a little bit of summary of what we've heard about here. I thought it's been a fascinating session for me. I hope everybody else has enjoyed it. So, I mean, what have we learned about the interplay between learning and consciousness? Well, we've seen that we still have a long way to go in terms of improving our methodology. Jason really did a number on us there, showing quite clearly that we still have a long way to go and that there's still lots of the evidence from the current literature is flawed. So we've got issues there, which is really very important. We've seen from Lena that the evidence that more complex, action-dependent the behavior, the less likely it is to proceed in the absence of stimulus awareness, which is informing our understanding of these boundaries for conscious processing and function. It seems to be there is this necessity to support selective adaptive behavior, as we've been hearing. And then we've seen that in contrast to sort of truly unaware stimuli, that in instances where where it can proceed is under situations where it's procedure unaware, so it's implicit, but where the stimuli are consciously perceived, but the underlying structural knowledge may remain outside of conscious awareness. And there we do seem to be able to see this and see this sort of learning take place. And we've seen from this wonderful talk by Professor Jablonka that how this might all fit into the wider evolutionary story with consciousness, not only being required for certain forms of learning, but with some forms of it, this sort of unlimited associative learning, potentially providing a marker for minimal consciousness, which is a fascinating concept. So I'm going to shut up at this point and ask the speakers if you could all come up and take a seat, make sure your mics are on, and then we've got a little while, about 15 minutes to ask whatever questions you have for any of the speakers today. Pardon? Yeah, okay. We might be a little short. If you can check that your mics are on, that'd be great. And I will do my usual run around and pass the mic.
Yes, thanks very much to all of the speakers. I wanted to ask all of you what your views are on the function of consciousness. I think I know Eva's view on this question, but I don't know the rest of your views. Do you think we're in a position to even have credible hypotheses? And if so, what would your hypotheses be?
Okay, shall I go first? So my intuition from this line of work that we have been doing is that the function of consciousness is to enable fast, adaptable, and flexible behavior. So I really like the view that it has consciousness is kind of co-evolved with learning as a manner of supporting more and more complex of learning, especially where we need to start learning very complex and fastly adaptable behaviors in a changing world. That would be my view.
Okay, well, this is a really tough question, but I think that consciousness definitely helps with flexibility and with matching your behavior to the specificities of the context in which you are. And maybe a less investigated function of consciousness that somehow emerged from our studies was that consciousness might help monitor and maybe map the contents of the unconscious. And we saw those fringe cases, those cases of fringe consciousness in which you have a feeling that you know something, but you do not know what you actually know. So yeah, I think that might be an interesting topic for further investigation.
Yeah, I think it has been said. I think flexibility, also combining multiple elements seems to be supported by consciousness. I think adapting to the environment generally is the goal or the function it serves. So same with fear. For a lot of things you're afraid of, you seem to be aware of it, or things you experience like pain or value of pleasure, you seem to be very aware of it. So seems to guide adaptiveness, maybe very flexible adaptations, definitely in humans. So yeah, I think that's the function of it.
Eva, would you like to add?
Me? Well, for me, it is yes. I mean, this is what the kind of things that that learning allows, that flexible learning of the type that unlimited associative learning allows, are extraordinarily adaptive. I mean, this is adaptation in real time and to changing environments and to many different contingencies. If you have this ability, if you can see, if you can discriminate between different aspects of the world, between different aspects of your own actions, if you have complex self-learning and complex world learning, well, you know, you are a winner. And we believe that this was indeed the case. That the first vertebrates, that the vertebrates and some of the arthropods that evolved this capacity were the winners. And in many there were, well, first of all, the arthropods, they were the predators in the Cambrian. They were the most the first vertebrates were kind of you know, modest little creatures, but very clever, because they had to escape the terrible predators of the terrible arthropods, clever arthropods. So they evolved their own unlimited associative learning and consciousness. So there was a coevolution. There was kind of evolutionary learning arm race, we believe, in the case of arthropods and vertebrates in very early on. But obviously, wherever it evolved, when it evolved, when unlimited associative learning and by inference minimal consciousness evolved, it is an incredible adaptation.
Thank you. I think there's some coherence there, which is nice. So it was a great question. 1 second, another question.
Thank you. I wonder if you could reflect a bit on the domain specificity of these kinds of learning. There's domain general stuff going on, but you've all worked with some specific stimuli. And I'm also curious to hear your reflections on the relation between learning systems and memory systems, mnemonic systems.
Okay, I can go first on this one. So the learning effects, the unconscious learning effects that we found in some of the studies were actually quite small. So I would expect that they would not transfer so well if we would change the stimuli or the context and so on, because the learning effect, the unconscious learning effect, was relatively small to begin with. So if you add more difficulty for these unconscious processes, I would expect that these unconscious effects would basically vanish, at least in the type of paradigms that we used. But there are other unconscious learning paradigms, and Ryan and Zoltan have some work on this, where, for instance, in the artificial grammar learning task, you present participants with letter strings made from one grammar, then you preserve the grammar but change the letter strings. So they follow the same structure, but you change the surface stimuli, and there is some sort of transfer there. So in some simple context, simple learning tasks, there might be some generalization, but not so much in these more complex processes that we were trying to investigate.
Yeah, I would agree with that. We are also constantly trying to find ways to change the task or amend the task in order to find under what conditions some evidence of learning might appear. So like we have already switched to using faces as stimuli, thinking about using, for example, smells as reinforcers, given that it's a very potent outcome stimulus. So I kind of agree with Razvan on that it seems to be already a very simple, very primitive kind of a task. I mean, we have 100% deterministic tasks. They're very simple to learn. There's not much scope for increasing the complexity, but maybe some scope for increasing the sensitivity of those tasks.
Yeah, with regard to modularity and consciousness, I've, at least with regard to different sensory systems, I think it seems to be just a domain general thing. At least awareness and associative learning, you could do it with shocks, you can do it with sounds, you can do it with odors, you can do it with everything we can perceive, tastes, that's fine. We can do associative learning with all the things we can perceive, not with UV radiation or something, because we can't perceive that. So at least the things we can sensory perceive seems to work with all sorts of associative learning paradigms. Maybe one dimension that maybe you can distinguish, I think not with regard to awareness and learning, but maybe just what is relevant for humans is maybe the difference between pain and pleasure, reward and punishment. That seems to be maybe distinguishable. But otherwise, I think with regard to associative learning or this kind of learning paradigms, I think is quite domain general. We can learn associations or the pairing regularities between all sorts of stimuli.
Yeah, if I may, I just want to say something. There would be domain specificity, of course, with regard to the inputs, and with regard to inputs and outputs, and the processes the processes that associate between them will be much more domain general. That is clear. However, one has to think also about the evolution of the systems. For example, you asked about the relationship between memory and consciousness. We think that the evolution of the kind of memory that we're interested in, the kind of declarative or proto-declarative memory, already requires that a lot of the perceptual integration. There is a lot of perceptual integration, that events are sort of represented in the brain to some extent, even if not all aspects of the event are not. For example, maybe the temporal aspect is less represented, but spatial aspects and the what and where aspects are represented, and to some extent maybe also later a when aspect. All this requires already a huge amount of integration, which makes sense of the fact that there is, that in fish, at least as we found, that it seems to be the case that the place where the GNW seems to occur is this is the memory system, is the hippocampus homocampus. However, we do know also that the hippocampus had deteriorated, for example, in some lineages. For example, in cetaceans, in whales and dolphins, there's hardly any hippocampus, and the functions of the hippocampus are now in the neocortex. So we really have to follow in order to see the connection between memory in different between memory and consciousness. It might be somewhat different in different lineages, even within the vertebrate within the mammalian lineage.
That's great. Well, we've got a couple more questions, and I don't want us to run on too long in case people want to get to the poster session. So,
I just have a quick question for Ava. Have you thought of applying your model to artificial intelligence?
I'm
sorry. Have you thought of applying your model not only to fish, but to artificial intelligence?
Yes. So we looked at this, and there are now there is an interesting model by one of the developers of this GPTs that has a model that also connects different perceptual effector, memory, reinforcement units in order to form the future kind of GPT model. And in some ways, this is also quite similar to the kind of toy model that I have presented, which made us smile. However, what I think is, yes, you can apply. I think we don't have unlimited associative learning in any present robot or artificial machine. We have all kinds of very domain-specific, now domain-specific, even if they are broad, linguistic, for example, but still linguistic. You have learning capacities at specific in specific domains, but we think that in order to have something like UAL and minimal consciousness in machines, you would have to have a certain type of embodiment. And we believe that also ontogeny, not only behavior, not only learning ontogeny, the ontogeny of learning itself, behavioral kind of how sequentially there is more and more ability to learn, to generalize, to transfer, and so on, but also possibly morphological ontogeny, which leads to new kind of affordances, bodily kind of changes that in size, in shape, and so on, are maybe also very important for the development of something like UAL or minimal consciousness in future machines, because of the many, many affordances that this kind of processes, the ontogenetic processes, allow. And we're far from it.
Thanks. Yeah, so my question, so we heard a lot about learning and its relation to consciousness. And so I agree with Lina that I think the reason for consciousness, so to say, would be like as flexible behavior as possible. And also, as Eva was quoting William James, so I mean, but for the presence of consciousness, right, there would be nothing for which we could for which a system could change, because it would not perceive anything, right? So in this sense, now I'm not convinced about, so let's put it this way. The consciousness, I believe the unlimited associative learning system, it might be somehow connected also to global workspace approach, in the sense of that, yes, consciousness, if a lot of modules have access to it, then they can, and then learning in a kind of reinforcement way takes place, then we can get more and more flexible and so on and learn. However, let's say I take a system, as it has already learned something, and now it doesn't need learning anymore in order to be conscious, right? So learning is in this sense not necessary for the consciousness, I would say. And so I don't know if it really makes sense to say that, okay, at this point in the evolution, there we have a certain system which allows a certain complexity of learning, and which allows a certain power, so to say, to emerge in these systems. But but I wouldn't say that this means that now there is suddenly consciousness. It just seems more like, okay, now there is this form of consciousness which allows a certain form of learning, so to say. So I would say, now, for example, I brought this stone as a little bit as a kind of a provocative thing here. But if like it can, so if we go with William James, like the stone can be really flexible in the sense that if you put a hammer on it or something, it's a recurrent network which will have different modes of vibration and give the energy back to the environment. So in a sense, like if we go with William James, and if we say, okay, consciousness is there just so that you have the chance to move at all in a flexible way, then I mean, I guess even the stone is probably not able to learn in the sense as you have been showing here. It might still have a measure of consciousness. Would you say that is wrong, or that you definitely say that? I don't know if I believe it in myself. I'm just saying that doesn't seem to be against what you say.
I mean, the first thought I had about this is that it's not just about action, it's about self-initiated action, right? So a stone won't really move on its own, even if the effect can be somehow, I don't know, adaptable, as you said, in terms of giving energy back, right? Stone won't initiate anything in order to gain rewards and avoid punishment. And I think this is a difference. I don't know if the others would agree.
I think that's a good response as I would be able to provide. Anybody else want to say anything on that?
We had a list of capacities. That's why we had the whole list of capacities. It's not just the capacity to respond. It's not an input-output response. For input-output, you don't need consciousness. what the whole point of this whole list was to specify particular capacities that are specific to the conscious state as we know it. Consciousness as we know it, which is the only which is animal consciousness, which is the only consciousness we know. And I think that obviously, well, we looked at consciousness from an evolutionary perspective to see how it evolved. Once it evolved, of course, a baby, even if it before it learns anything, is conscious because it has the machinery there, which allows it to integrate, to evaluate, to do all these kind of things. So yes, once ontogeny does not recapitulate phylogeny in this case.
That's right. I'm very conscious that people might want to get to the poster session, so I think I should probably bring it to an end there. But please join me in thanking all the speakers. Thank you all for all the fabulous questions and for joining us here. I've really enjoyed the session myself. I hope you've all taken as much from it as I have. It's been really great. And hopefully we'll get to carry on talking over coffee and all the posters and everything else. So thank you, everybody. And thank you again, speakers. That's been great.
Thank you.
Thanks. Thank you all.